Good evening, friends. Today I have tried to give some practical example as far as possible. This is the basic idea, and after my retirement, it may be possible that they have changed their system. So take some basic idea to design a capacitor bank. Suppose the average maximum demand of a year is 20 megavolt ampere. For JCB, it was noticed that without capacitor bank, its power factor was 0.70, and penalty they were imposing at 0.85. So what we should do? We raise the power factor from 0.70 to 0.85 or more. The lagging KVR will be neutralized by the leading KVR. So the angle between megawatt and MVA will reduce, and according their requirement, no penalty will be imposed as the angle reduced to less than 30 degree. But for OSB, you have to raise above 0.90, but their initial power factor is more. So the system almost same to raise the power factor. In our time, I shown it here. Let's see, now discuss. Let our traction substation having 20 MVA average maximum demand for a year. So this 20 MVA, for this 20 MVA at 0.70 power factor without capacitor bank, the KVR will be calculated. Then with 0.85 power factor, the KVR will be calculated. Then if you subtract KVR1 and KVR2, then the KVR neutralized by capacitors can be easily found out. So we did it here, or we have done it here, and it is showing 5600 kVAr. We are taking 10% extra for future growth. So multiply it with 1.1 for 10% increase. It will show 6200 kVAr. Again, there is a formula, XC is equal to kV square into 1000 by kVAr. In my previous discussion, I have shown how to derive, I have derived it. So the formula is XC is equal to kV square into 1000 by kVAr. But our bus voltage phase to earth is taken 40 kV after harmonics analysis. Instead of 25 kV, we calculate with 40 kV. So kV square means 40 into 40 into 1000 divided by 6200, say 258.06 ohm. The unit of XC will be ohm. Now Xc minus 0.13 Xc means this Xc is the resultant Xc of Xc for capacitance and X for neutralize XL value, the required Xc, that is 0.13 Xc. 13% of the Xc will be the rating of the series reactor. So the resultant Xc will increase. Xc minus 0.13 Xc is equal to 258.06. This is the resultant, and actual required is 297 ohm. Now we know the formula Xc is equal to 1 by 2 pi Fc. From there we can easily derive the capacitance value. It is showing 10.7 microfarad. Now the capacitor unit nowadays available is 220 kVAr at 8 kV. The voltage will be taken as 40 kV. The Xc of each unit, again the same formula, kV into 1000 by kVAr, means here the voltage is 8, so 8 into 8 into 1000 by 220. It is coming around 290.90 ohm. So capacitance, again that formula, X is equal to 1 by 2 pi Fc, C is equal to 10.9 microfarad. Our calculated value is 10.7 and the capacitor unit is 10.9 microfarad. Now we have to arrange this microfarad with the help of this capacitor unit. Its rating is 8 kV, but our bus voltage is 40 kV. So we will take 5 capacitors in series so that each capacitor will absorb 8 kV. 5 into 8 is equal to 40 kV. Now, to how many parallel string will come, that can be calculated from the resultant capacitance, and it has been seen that number of parallel path will also be 5. Then the required capacitance we can achieve. Let's see how. Here the orientation of the capacitor bank has been shown, 5 in series and 5 in parallel. So the resultant capacitance, we know the formula is 10.9 for 5 parallel into 5 and for 5 series divided by 5. So it is coming around 10.9 and our calculated value is 10.7. So it is close to there. You can increase the capacitance more because nowadays the meter not calculating the leading power factor. So if you add more capacitors, the leading factor will arrive and again the power factor will come low. But now it is ignored, so we can add more capacitors to reduce the penalty or stop the penalty. Thank you friends. Good evening. All is well. Be happy. Thank you.